Hi, my name is Anshul and
my name is Vaibhaw.
The short video that you're about to see is a documentation of the new device that we've created.
This device is called the Gesture Control RTV. RTV stands for Rough Terrain Vehicle.
On the 20th of September of 2017, Mexico was struck by a 7.1 magnitude earthquake, the result of which were 217 fatalities and several collapsed buildings and establishments.
This sparked in our minds an idea. The idea to create a robotic car which functioned almost as an extension of the human body and could go into territories that are hazardous to people, such as collapsed buildings, caves with toxic gases, or even similar other situations.
A glove acts as the car's controller, where bending fingers adjusts the acceleration and hand rotation changes the car's direction.
The car's acceleration is controlled by changing the level of bending of the fingers in the glove. This was done by attaching flex sensors inside the glove. This sensor returns different values based on the level of bending, which can be seen on the graph in the screen. For attachment to the glove, there were two wires and a resistor connected to the base of the sensor with a heat shrink.
The next sensor used was the passive infrared sensor so that the survivors of a hazard could be detected. As can be seen in this video, the sensor detects any change in passive infrared heat emanated by humans.
Finally, to detect a change in the orientation of the hand, we used a BN0055 gyroscope that could easily detect a change in the orientation of the hand around the x-axis. The resulting changes can be seen in the video.
Finally, we attached the flex sensor, the gyroscope, and the Bluetooth master to the glove, and the PIR sensor, the SD card shield, and the Bluetooth slave onto the car so that it could work in unison. This is what the final working product looks like.
Throughout this project, there were a number of challenges that we had to deal with. Firstly, we had trouble with the base rover due to a misalignment in the back wheel mechanism. To fix this issue, we attached a transformer as dead weight so that both wheels and motors could grip the ground adequately and the rover could move properly on any surface. Second, we had trouble with the flex sensors over time. The readings became noisy, therefore we could no longer have the 10 different speed modes based on finger bending that we liked. Instead, we changed to 3 different accelerations to ensure smooth performance for the user. Another major issue that we had to deal with was with the PIR sensors. They were incorrectly calibrated to match human movement efficiently, so we adjusted the sensitivity and the delay on the chip itself using a screwdriver. Now the PIR can accurately detect any motion around and can find humans in an emergency situation. Our last major issue was with the Bluetooth pairing between the slave and master modules. We 3D printed a case to improve the aesthetics of the rover and to protect the wiring from the environment, but this interfered with the sensitive connection to the glove. We then removed the case because of this, but the Bluetooth signal between the two devices still remains weak. The user simply has to remain close to the rover for proper function. This product was inspired by the disaster in Mexico and aims to fill the market gap of freely available, inexpensive mobile search and rescue machines to assist emergency first responders in any situation imaginable. Devices like this have a lot of potential. With the same peripherals and algorithms hooked up to a small drone, the versatility of this device can be further magnified by a functioning industry, and who knows, maybe even a company could be built upon this idea.